OK. So let's kind of forget about this formula up here. So we need to find the formula for this. So I have my first 5 terms are 1, -1, 1, -1, and 1. And now I want to be able to figure out the rule. So we automatically know that we have positive to negative, positive to negative. So we have alternating signs. So first of all, what was our rule that we talked about for at least alternating signs? Right. But what did we start? Remember in that last formula? How do we? -1 raised to the n, right? OK. But here's where our problem was, which I talked about. Remember I said the FYI last time? So if I put a 1 in for here, that means my first term is going to be negative. So I need my first term, since my first term is positive, I need this number to be positive. So it's not going to be -1 raised to the n. It's going to be -1 raised to the n plus 1, right? Because now if I put 1 in for there, 1 plus 1 is 2, so that's positive. Then if I put 2, 2 plus 1 is negative, so then, or is odd, so then that would be negative. So now we got the positive and the negatives correct, right? Good. All right, now let's look at the numbers. So we need to keep 1 the whole time. Yes? OK. So how are we going to get the number 1 every single time? No matter what number, I have to plug these in for n, but I always have to get 1. Well, let's just go and check out our first terms, guys. Let's do a sub 1 equals -1 to the 1 plus 1. That's 2 equals 1. Yeah, a sub 2 equals -1 to the 2 plus 1. So you guys notice this is actually already our rule. We already created it, right? Because if you take 1, it doesn't matter what you raise 1 to, 1, 2 to 3 to 4, 1 to 5, you're always going to get 1, right? Those all equal 1. So as long as you have your base of 1, raise it to whatever number you want to, you're always going to get 1. But we wanted to keep our base as negative so we could use our alternating powers. OK? So that would just simply be a rule. OK? And that's it.
What number is it?
That was 51, I believe.